A cylinder with height 2h is going to be cut from a solid sphere with radius 4 centimeters. Express the radius of the cylinder in terms of h, hence find the value of h, which gives a maximum possible volume. Okay, so if we go to this GeoGebra app, and the GeoGebra app I will put in the notes of the video. So here we have a cylinder inside a sphere. If I change the height of the cylinder, and don't forget each edge of the cylinder has to touch, you can get different volumes, and one of these values of the height will give a maximum volume for the cylinder. Okay, so the secret of this question is this bit here in the middle, which is sort of going to be using a little bit of Pythagoras. So if we just look at different angles here, okay, so this is 2h, this is going to be h, this is going to be 4, which is the radius of the sphere, and r is the radius of the cylinder. So if we go back to the problem, so just repeating that, this is the center of the sphere, this is h, which is the height, half the height of the cylinder, this is going to be 4, and this is going to be the radius of the cylinder. The 4 is because it's the radius of the sphere. So drawing that right angle triangle out, so we can see it a bit more clearly, we've got R, and a good problem solving technique is always to draw a diagram, H and 4, and then R is the radius and H is half the height of the cylinder. Okay, so we require R in terms of H. So from Pythagoras, we can say that 4 squared, because that's the hypotenuse along his side, is going to be equal to R squared plus H squared. And then if we make R squared the subject, then R squared will be equal to 4 minus H squared, which means that R will be the square root of 4 squared, which is 16, minus H squared. Now, in order to find the volume of a cylinder, so we now got R in terms of H, then the volume of a cylinder is pi r squared h. This h is not to be confused with this one. H is the total height of a cylinder and r is its radius. So we have that r is going to be 16 minus h squared, and that the height is going to be 2h. So substituting that into there, we're going to get that the V, the volume, is going to be pi times the radius, so square root of 16 minus h squared all squared, times my height of my cylinder is 2h. Right, if you square root and square, you're left with the same thing. And then we got 2h. 2h times pi will become 2 pi h. And then this, if you square root it and square it, will just become 16 minus h squared. We're going to sort of differentiate. So before we differentiate, we can multiply that out. So we're going to get 32 pi h minus 2 pi h cubed, because h times h squared is h cubed. Now, in order to find a maximum, we need to find dv by dh, so that we differentiate the volume with respect to its height. So we're going to have that dv by dh is going to be equal to, now if you differentiate this 32 pi h, you just get 32 pi. If you differentiate that 3 comes down in front, so we get minus 6 pi h squared, reducing the power by 1. For a maximum, we normally put dv, the derivative, equal to 0. So dv by dh have to be equal to 0. So we're going to put this equal to 0 and then solve it. Looks quite difficult, but it actually isn't in practice. So we've still got the diagram there, so we can refer to it. So if we take this over here, we're going to get 32 pi is equal to 6 pi h squared. If we divide by pi, we're going to get h squared will be 32 pi divided by 6 pi. The pi's will cancel out, and then 2 goes into 6 3 times into 32, 16 times. So we get that h will be the square root of 16 divided by 3. The square root of 16 is 4, so this becomes 4 over root 3. If we multiply bottom top by root 3, which we were supposed to do, then the exact answer for the height will be 4 root 3 over 3 centimetres, and that's approximately 2.31 centimetres. Now, we have to verify that this is a maximum. So if this was the first derivative, if we differentiate again, so d squared v over dh squared. So if you differentiate 32 pi, you get nothing. If you differentiate this, you're going to get minus 12 pi h. So you get minus 12 pi h, so you bring down that 2 in front and reduce the power by 1. If we put our value of h in, which is a positive value, the answer is going to come out to be negative. We don't actually have to work it out, so the second derivative is less than 0. So if we got a derivative equal to 0 and a second derivative negative, then we have a maximum point. So this value of h will give the maximum volume. In order to find the maximum volume, we would now put v back into v, the value of h. So we're going to have 32 pi root 4 root 3 over 3 minus 2 pi 4 root 3 over 3 cubed. Right, if you put this in your calculator and then put this in insert form as well, you're going to get 154.77, which will give a volume of 155 centimeters cubed to 3 significant figures. So going back to the GeoGebra applet, so if we move our value of h, so it was 2.31, that there we get the maximum volume. If we move h to be less than that, we'll see that it gets smaller, and if we move past it, then we'll see again that h will get smaller as well. So that will give me the 2.31 will give me the maximum, the maximum volume for this problem. Okay, so this GeoGebra applet I'll put in the notes of the video. I hope you've understood, and I thank you very much for watching.